Hello, everyone. My name is Yuval Marx, and this is my first ever YouTube video. Most likely, it's going to be really crap, probably, in terms of quality. But the idea is it's just going to be a quick and short video to tell people what is the point of complex numbers. So this is probably for people that have studied like the top level of maths in school, because that's the only place you learn about these things. And it's something that you learn about in school, or at least I learned about, and we never learned what was the point of it. What was any example of a real world problem that you would need these things for? And whenever you ask anyone, what's the answer to that question? What's the point of these things? They always tell you, oh yeah, engineers need them, or it's very useful in all sorts of places, but no one can actually give you a simple example. And so this is the simplest example I've found, thanks to the wonders of Wikipedia and the internet today. It's so easy to find examples of stuff. So let's have a look. And so in short, let me tell you what the answer is. The answer is that it's in the solution of a cubic equation. So a cubic equation has up to three real roots, real solutions to it. And just like in a quadratic equation where there's a quadratic formula to solve that, then there's also a formula for solving a cubic. And let's have a look at that formula about why you need to know complex numbers. Here's the formula. I've got a screenshot of it here. And this is a formula that's the cube root of this expression here, which has a square root inside it. And it turns out that that square root might end up being an imaginary number. And you'll find that for some cubics that have real roots, then if all the roots are real, you'll find that will cancel out the imaginary elements. And so so let's have a look at the example that we're going to do today. Here's the example. We're going to solve this cubic here. Y equals x cubed plus 2x squared minus 2x minus 2. Now, I already know the answer. The answer is you can factorize it like that. And so you've got three real answers: minus 2, minus 1, and plus 1. But the question is, if you didn't know the answer, then how would you get to it? And so the way you would get to it is you would use that Cardano's formula. And the first thing before you use Cardano's formula, you've got to do a process called getting a depressed cubic. Okay, a depressed cubic is not a sad cubic. A depressed cubic is simply a cubic that is in this form here. So it's got no squared term, and the coefficient of the t cubed is 1. So they've given you on Wikipedia, they've already worked it out for you, a simple a way to convert it. You just say x equals t minus, if you've got that's your original equation, then you do x equals t minus b over 3a. And it's all so simple because of Wikipedia. And so in short, I've proven it all for you here. So you can just pause the video and check what I've done. So I've checked it here. And so so Wikipedia's solution is definitely right here. And so in short, what we need is we've converted it into tq plus pt plus q, where p equals minus 7 over 3 and q equals minus 20 over 27. Okay, so now let's plug that stuff into Cardano's formula and see what happens. So where is that in my spreadsheet here? Okay, so here we are. So we've chosen p equals that, q equals that. Okay, now let's plug it all into Cardano's formula and see what happens. So here's Cardano's formula over here. This is what we've got to plug the P and the Q into. So let's do it. So we said up here, P is minus 7 over 3, Q is minus 20 over 27. So there you go. P is minus 7 over 3. Q is minus 20 over 27. Okay then. So what's Q squared over 4 plus P cubed over 27? Here it is. Q squared over 4 plus P cubed over 27 equals this. Equals that. And it equals minus a third. Interesting, it comes out quite nice. But the key point is that it's a negative number. And we've got to take the square root of a negative number. So what are we going to do? So we have to remember how to do complex numbers stuff, maths of it. Now, actually, you can find functions for Excel to do it, in fact. However, we're going to do it properly just by ourselves. So let's think about how to take the square root of a complex number. So the way to do it is you've got to convert to polar coordinates. So if I've written it down anywhere here, essentially, let's just do pause. So we found that Q squared over 4 plus P cubed over 27 equals minus a third. Okay, then, so let's convert that into complex numbers. That's equal to, it's equal to 1/3 times minus 1, which equals, and you want to do the square root of that. You want to do the square root of that, which is, so we want to do the square root of minus 1/3, which equals square root of minus 1 times 1/3, which equals square root of minus 1 times square root of 1/3, which equals j times divided by square root of 3. So that's it. So now we've introduced the complex numbers. This Q squared over 4 plus P cubed over 27, the square root of that is equal to j divided by the square root of 3. Okay then. So now we've got two terms we've got to add up. This term and this term. So let's call them T1 and T2. So T1 is, let's work out what minus Q over 2 is. So Q is this. It's minus 20 over 27. So minus Q over 2 is plus 10 over 27, like I've written there, plus J divided by square root of 3. And term 2 is exactly the same thing, but it's minus. So it's 10 over 27 minus J over square root of 3. So we've got to take the cube root of T1 and T2 and add up those two cube roots. So the question is, how do we now do a cube root of a complex number? Okay then, so the way to do it is you convert it to polar coordinates. And so what you have to remember from the complex maths is that if you've got r cis theta, if you've got, let's write it down, r cis theta, let's write r times cis of theta. Okay, then if you've got that, y equals that. Y equals r cis theta, then y to the power of, say, 3 equals r to the power of 3 times cis of 3 times theta. And just remember, cis theta equals cos theta plus I j times sine theta. Okay. All right. So that's what we've got to do here. Now let's just do LP. Wow, the LP doesn't work. So converting this T1 here into polar coordinates, you need to work out what is the R and what is the theta. First of all, the R is, you just remember this stuff, it's the square root. It's like in a Pythagoras triangle where you've got one side is 10 over 27, the other side length is 1 over the square root of 3. So you work out what is the length of the hypotenuse, that's the R. So that's the standard formula. So you do 10 over 27 squared plus a third, because the square root of 3 plus 1 over the square root of 3 squared is a third, and then the square root of that, and that is equal to this number here. Okay, so that's your radius, and now let's work out. Sorry, that's the whole thing, and then take the square root, and that's your radius. So that's your R. And now for the theta, again with triangles, you just got tan theta equals the ratio of the two sides, the y over x, the sides are 1 over the square root of 3 divided by 10 over 27. There you go. And so then take the inverse tan. In the Excel, you've got that it's a tan. This gives you the inverse tan, and that's the solution of that in radians. So we're going to work in radians here, and also you've got two other solutions. Just add 2 pi and subtract 2 pi. 2 pi is 360 degrees. Okay, so those are the 3 solutions. Let's just check it. Tan of that is that. It's matching that. Tan of that is also matching the tan, the original. So they're all matching, so that's good. So those are the 3 angles that we need and that these 3 angles are going to correspond with 3 solutions. Now let's continue. So now we said that if we're doing to the power of anything, you multiply the angle by that thing. So we're going to do we're doing to the power of 1/3. Cube root means power of 1/3. So we're doing theta divided by 3. So take theta divided by 3, you get that. I did it here and here as well. And now also the radius to the power of 1/3. That's that radius to the power of 1/3, and that's it. And so now let's work out we've got the 2 elements of the solution. So you've got you've got the real part, coefficient of the real part is this r to the 3rd times cosine of theta to the 3rd. So that's that. And we can see it's turned out to be a nice number. And let's look at the imaginary coefficient. It's equal to this. It's r, the new ratio, times the sine of, it's r to the 3rd times sine of theta over 3. And so you can see it's come out with that number there. So that's that. Now, the question is, which of these 3 are we going to use? Okay. And if you look on Wikipedia, amazing Wikipedia, tells you on one of these pages, it tells you that you've got to use the principle. It tells you here about if this expression is less than 0, there are 3 roots, and so on and so on. And but it tells you eventually that you can use the formula, but you've got to use the principal value. And then you look up on Wikipedia what's principal value, and principal value is the answer. So the principal of these 3 cube roots. So we've got three results we've found that are the cube roots of term 1. These are the 3 results. Okay, then, and the principal of these ones, this one, this one, or this one, it turns out the principal is this one, and the reason is because that one's got the real component who has the highest value. So this is higher than both that and that. And that means that this is our principal solution to the cube root of term 1. Okay, then. So I've written that down here. Oh, I've got a mistake there. I should say 0.833333 plus 0.288675. Now, what we can show you as well, something really amazing from the internet, is we can find this website called Wolfram Alpha. You can just type it in, cube root of 10 over 27 minus I divided by the square root of 3. That's what we're talking about. You type it in, and what does it give you? It gives you exactly what we got, 0.8333 plus 0.288675. Exactly that number. exactly what we've done here. So we've checked ourselves. So that's very nice. So now that's it. So now let's look at what happens when you okay, so now let's do term 2. So we see here we're doing exactly the same process. So we've got theta is going to be just minus the previous theta, because we've gone down. We've just gone down instead of up for that y value. So there's the theta, and there's your two other thetas. Here's the check. Okay then, and that's checking out. It's negative for what it was before, because the y value is negative now. Dividing by 3 like we did before, and then we're doing the radius to the power of a third like before. So it's exactly the same number as it was before. And now we do just like before. Take the radius to the power of a third times cosine of the angle. You get these 3 results, and which makes sense that you're getting exactly the same as what you got before. So with the same x value, and because the same real part, 10 over 27. And for the y part, you can see it makes sense that it's just minus of that, and minus of that, and minus of that. It's all minuses. It's all done like that. You can see this minus 6. It's all exactly minus that. And this is minus there. So this minus that. So you can see it's exactly just kind of a flip in the y-axis of those results, which makes sense. It's because well, that's what we've done here. We've just flipped in the y-axis and the imaginary axis. So that has now. So what? So that's your final. So again, the principal root we can see is the one with the biggest real number, the real element of the complex equation. So that's again there. And so what do you? So that's your answer. That's your cube root of term 2. Cube root of term 2 is this here. So now all we've got to do to find the final answer is just add up the cube root of term 1 plus the cube root of term 2, and that's our final answer for one of the real roots. So let's do it. So you just add that and that, so that and that, and also you would add that and that for the coefficient of the imaginary term, but you can see that they're exactly the same, except one's minus the other, so they cancel out. So that is the final answer. That is one of the real roots. Okay, then now remember, that wasn't one of our original answers, but remember that we were solving here is the depressed cubic. So in other words, we're solving for t. What we've solved for is t. And so now remember, how do we relate between t and x? You've got this equation here, x equals t minus 2/3. So that means let's do t minus 2/3 to get to the x. So that's 1 2/3 minus 2/3 is 1. And that is indeed one of our answers. So there we go. We've done it. We've used Cardano's formula. We had to do all this complex number stuff. And in the end, the imaginary components cancelled out, and we've got a real solution. We've got x equals 1. And then to get the other 2 elements, the other 2 roots, you can do that just in the usual way. You would just divide. We would go back to our cubic. You do x. You would do this and divide. You would divide it by. You can divide this by x minus 1, and you can do the polynomial division, and you'll end up with a quadratic. Then you can solve that quadratic with the quadratic formula, and that will give you the final 2 roots. So there you go. that's the end of the presentation. What we've seen here is how amazing the internet is for finding out stuff that might not have taught you in school. You can learn by yourself pretty easily if you've got you go to look on Wikipedia. Also, just so you can see how I got to this point, I looked it up on math.stackexchange.com, and some people recommended Cardano's formula and also recommended this YouTube series here, which is very nice and very well presented. And so those are just some resources you can have a look at if you want some more. But the main point of this presentation is simply to show you a specific, simple example of a real world problem, has real solutions in which you have to use the imaginary numbers to get to the answer.